Hi folks, Mr. Ackman here. Thanks for watching. Topic of today's video deals with how you report the results of your lab investigations using the computer. As you head into senior levels in high school and then into university, there's going to be less and less reliance on handwritten reports and more on computer reports. You want things to look professional. So today I'm going to focus on 4 things that you need to know, especially in physics, and these are as follows. When you are typing and when you are dealing with equations and you're showing substitutions into an equation, how do you type math symbols using Microsoft Word? This is also known as the equation editor, and I'm going to show it to you in this video. Another thing would be how to create data tables in Microsoft Word so that your data are presented in a professional manner. Another one is how to create graphs using Microsoft Excel. Excel is a very powerful graphing program, and it has some really neat features that I'm going to show you today. You're going to be able to make graphs in under 2 minutes in most cases. And finally, I'm going to show you how to create drawings that you would normally do by hand. You can make them look a little bit more professional by using a free download called Sketchbook Express. This is what I use. Of course, there are many others, and you're welcome to use whichever ones you want, but I'll just show you the one that I'm using. Anyway, let's get started. The first one is how to type equations and symbols into Word. So what you can do is load up Word, whichever version of it you have. Just so you know, for me, I'm on a Mac here, and I'm using version 14.4.2. You may have a different version. You may be using a PC. It's possible that the version you're using has slightly different features than mine. So this will give you an idea of how to create these math and physics symbols as well as the equations, but you may need to tweak it for your particular version. And if that's the case, then what you can do after watching this is something that all of us know how to do. Whenever we have a question, you have a choice. You can either just type it into Google. How do I type equations into Word, version whatever, or you can take this same question and put that into YouTube and find another video that will show you how to do it. So either way, I expect you, and I'm sure future teachers and employers are going to expect you to solve your own problems. And one of the great things about being alive these days is that you can easily find answers to many of your questions just by typing things into the computer here. So anyway, back to the version of Word that I'm using. If I needed an equation, what I would do is I would go Insert, I go down to Equation, and then a text box, a special text box is opened up. Now let's look at some basic equations. Suppose you were using speed equals distance over time. You could say something like V equals, and then you could do D slash T. But we can do a better job than this, because look what you've got up top here. You've got a button here for fractions, and since we are typing a fraction equation, or a rational equation, we now look for what type of fraction do I want it to look like. Quite often you'll see this, so go into the box, put D, arrow down, and T, click outside the box, and now your equation is starting to look more professional. Of course, you might say, hold on, wait a minute, it's not D that my teacher is using, it's actually delta D. So go up here, find the symbol you want, the Greek letter delta, delta D. Now go down to the bottom box, click in there, delete the T, make it delta T. And now your equation is starting to look even more professional. Of course, this might be, for those of you who are far enough along in physics that you've dealt with something called vectors, you might wonder, well, how do I put in the vector hat over delta D? So first of all, let me just zoom in here a little bit more so you can see a bit better. If you want the vector hat over delta D, then let's delete this first of all. In the equation tools, which is up here, so click that box if you've lost the equation tools on the top banner here. What this is for a vector hat is called an accent. So if you look here, you'll start to see as the boxes are populated, there's a vector symbol. So now when I go into that box, delta D, I have a vector. Delta T, of course, is a scalar. There's no vector there. But V over here probably should have a vector. So let's go accent. Let's do that again, and then call it V. Of course, you might think, wait a minute, this is actually the formula for average velocity. So I should really go back there, and now I need a subscript. So what you do is you go under script and you say, oh, there it is. So now what you can do is AV for average, and voila, you have yourself a fairly professional looking equation. And suppose you want to show me your substitutions. You want to show what numbers you've subbed in there, then just arrow get into the equation box there, put equals, sorry, I'm out of the box here, got to get into the box. There we go. Equals, go back to equation tools, set up another fraction, this time like this, go up, and now what you can do is you can start typing in, like maybe your delta D is 12 meters to the north, like this. And maybe your time is 12 seconds. And then we go equals, and that's going to be 1.0. We could do meters per second this way, but once again, just get that fraction box going. 1.0 up here for meters, whoops, and then down for seconds. Anyway, so on and so forth. Here's the final result. You can click and drag this, I believe. You can move it around, or at least you can just get outside the box and arrow down, or sorry, hit return and move down, hit delete and move back up, and so on and so forth. Here's a drop-down menu which gives you a few other options, and that's really all there is to it. You can take a look at some of the other options that there are here. Some of them you'll recognize, some of them you won't. Don't worry about them if you don't recognize them. At some point you'll be using them in university, but I think you get the idea. It's pretty much limitless what you can create here with the equation editor. If you're looking for some symbols that you don't see immediately, just arrow over. Here are some Greek symbols that we're familiar with, and so on and so forth. And that's it. There's your equation editor. Anytime you're typing an equation or you need symbols, you can do it in here. Okay, so I hope I've answered the first question about how do you do these equations and symbols. Next up, how do you create a data table in Microsoft Word? So let's go back to Word here, and suppose you are creating a data table for the movement of an object. So maybe we're measuring how far an object has moved at various different times. So maybe we want to know the time, and then we want to know where it's located, its position. So we can go under tables here, and you can create a new table. We want one column for the time, and we want one column for the position. So we create this data table, and we'll go time. First off, we want to write the name of the variable, the English name, so time, comma, the symbol, which is usually t for the actual time, as opposed to delta t in elapsed time. We would often put the units in brackets like this, and since time is just a scalar, there's no direction, so this is it. Now we can tab over to the next column header, and now we're going to have position. The symbol is D with a vector hat, so I can't just type in a vector hat. What I actually need to do here is go to Insert, an equation, and in here I want D with a vector hat, so I'm going to have to go Accent, like this, get into the box there, put D, now click outside the box, so position D, the units, regular brackets, they are in meters, and since this is a vector, I might have something like north of home, or whatever the reference point happens to be. Now just tab and start creating start entering the values. Maybe at time 0, your position is 0. Maybe at time 1 second, the position is 2 meters. At time 2 seconds, the position is 4 meters. At time 3 seconds, the position is 6 meters, and so on. And you're almost done here. I mean, this table is acceptable. There's nothing wrong with it. It's a little bit big. You can click and drag. Often you can move these in like that in order to make things a little bit more presentable, but it's not absolutely essential. It's just an aesthetics thing. You might decide that you want everything to be centered up, so choose center justification. That looks nice. Again, not essential. One thing that you should do is highlight this, right-click, or double-tap if you're using a Mac, and you should insert a caption. So a caption would be something like Table 1 or Figure 1. You can type in here the movement of a car. Click OK, and you get a caption there for your data table. And the caption should stay with the data table. Basically, your caption should always be something that's descriptive about what's going on. The worst caption you could put would be something like position and time. Anyone can see that it's position and time. Please tell me a little bit about what's going on. The movement of a car? Gotcha, I understand. If this is a lab and this is trial number 1, data for trial number 1, that sort of thing. And that in a nutshell is your data tables. There are other things that can go in here. For example, if you're watching and you're in my grade 12 class, you'll know that we've been dealing with something called uncertainties. So you might actually need to put a symbol in here. Maybe the time is known to within plus or minus a certain number of seconds. Well, you can either go insert equation. You can actually get the symbol for plus or minus in here. It's somewhere up here. There it is. And you can say something like plus or minus 0.1 seconds would be a possibility. Or another option that you may not know about, which I'll show you on this side, maybe the position is plus or minus 0.2 of a meter. So what you can do here, in this version of Word, it's called the media browser. You click this button and it opens up this window here. And you go under symbols, you click in where you want them, and you will find some of the common symbols. So there's a plus or minus. It looks a little bit different than the plus or minus here. The difference is this one's in its own little text box. This one isn't. This is like typing a character. So you might do something like plus or minus 0.2 of a meter. One other thing about these data tables, when the units are all the same for every entry, and they almost always will be, then you would put the units up here. You would never do seconds, 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 seconds. That means you're not being very efficient. You're writing more than you have to. The whole point of a data table is to efficiently communicate information. Same thing goes here. These are all meters, and if they're all plus or minus 0.1 second for time, and if they're all plus or minus 0.2 meters for position, then that as well should go up top here. Okay? Anyway, the rest of it is pretty straightforward as far as a word processor goes. I think most of you can handle it from here. So now I'm going to move on to the next question that we want to address, which is how to create a graph in Microsoft Excel. So let's tab over to that. Here I've got Excel open. Once again, what version am I using? This is version 14.4.2. Okay, you may have a different version. If so, and things are different, you know what to do. What I'm going to do here is, now you don't even need to type really the name of the variable that you're using if you don't want to. You can just very quickly put in these numbers. I usually make the x values, or the independent variable, in the first column and the dependent variable in the second column. Although do keep in mind, for a position time graph, while time is often the independent variable, so this is going to go x, that's going to come first. Position is usually y. There is sometimes you'll have a data table here where maybe things will be reversed. Maybe for some reason or another, the thing you're measuring is time. For instance, when is a car located at various different positions? If that's the case, all I'm trying to say here in a very long-winded sort of way is just try to keep things simple. Put your x's or horizontal variable here and your y's over here. So what's this going to look like? Horizontally, time on the x-axis, 0, 1, 2, 3. So 0, return, 1, return, 2, return, 3. And I believe these values were 0, 2, 4, 6. So 0, 2, 4, and 6. Highlight starting at the top here and dragging down. Go Charts. And now you'll be given some options. Now we want to make a scatter plot almost all of the time here. So let's see what they offer us. They offer us dots with no line connecting them, or dots with lines connecting them, or lines without the dots shown. The one to choose is this one here. Do not connect the dots. We're going to do that later. Once you click on this button, you're almost done. Your graph is basically complete. All that's left to do is label the information, the variables. So let's move this over a bit and see if we can drag this out, make it a little bit bigger. There's only one data series here, so we can click on the legend and delete it. And now let's go to work on this. What is missing? Well, there's only horizontal grid lines. So if you go to chart layout and you go to grid lines here, let's put in some vertical grid lines, major grid lines. Now, what are minor grid lines? That just means if you want finer divisions, then you go like this, and we can do the same with the horizontal. How big are major and minor grid lines? You can set that. There are some options here which I'll try to get to in a moment, but already the graph is starting to look nicer. Let's give the chart a title. Put the title above the chart. That's fine. Start typing. The motion of a car on Bayview Avenue, for instance. So now we have a title for the chart. Once again, something like position time chart, not a good title. Something descriptive, much better. The axis titles on the horizontal axis, where are we going to put this? Let's put it below, and you can highlight this. You might want to make this a little bit bigger, so right-click or double-tap if you're on a Mac. Go Font. Give the computer time to figure out what it wants to do. There we go. Maybe make the font size a little bit bigger, maybe 12 or 14 or 16 point. Now we can read that a little bit better. So this is time t in seconds. Should correspond with what you had over here. Don't worry about the uncertainty if you're a grade 12 student listening to this. We'll talk about that in a moment. Do the same for axis titles vertical. Now you get some choices. You can have it done horizontally, which is a little awkward. It's going to push the chart out. So we want a vertical title, but we actually want it rotated so that it types sideways like this, as opposed to typing vertically. Let's increase the font size like we did on the horizontal axis. I think we went up to 16. That should be good. So now this one is position, and remember it's the vector symbol D. I'm just going to put in the letter D for now, and I'll tell you why in a second. The units were meters, and the direction was north of home. Now, with the D here, which should be D vector in the case of position, I have struggled with this in the past. I've tried to actually type D with a vector in here. In fact, let's try this now. Let's see if I can copy this. So I've actually just hit Control Copy. And let's see if I can paste that in here. I think the answer is no, because I tried this once before, but let's see. Paste, and I get a little bit of a disaster there. It's the wrong size. However, it's also not got the vector symbol. One of my students once found out how to do this, but never told me how to do it because we never got around to the conversation. However, what I would encourage all of you to do is what I've been preaching, which is if you don't know the answer, go to YouTube or just go to the internet. And again, how do I include vector symbols in Microsoft Excel? And maybe it will be a video, maybe there will be a forum where you can actually put that in. I don't want to take up your time on this video any more than I already have, so I'll leave that to the viewer to do. What's left to do here? We should probably click on one of these data points, highlighting everything, and include what's called a trend line. What kind of trend line? Let's look at the options. You're given a choice of linear, a straight line, logarithmic, which if you don't understand logarithms, don't worry about it, polynomials, which can either curve up or down or wiggle, for example, like a cubic function. Power curves we sometimes use, more on those later in the course. Exponentials don't come up as often in the grade 12 course, but they could sometimes. And moving average you'll see very rarely. I think you can tell from the data that I created here just fictitiously, it looks like a linear trend. Time goes up by 1 second, each time position increases by 2. This is linear, so we type this. Under options, you have an interesting choice. You can display the equation, so the y equals mx plus b equation on chart, which is kind of nice to have. When you do this, a line of best fit will be created. This box here will actually show, and if you highlight it and increase the font size so that you can see it a bit better, you'll actually see what is the equation of the line, which will tell you a little bit about the trend of your data. So maybe put that somewhere down here. And there you go. you can always edit this trend line, you can modify it. If you go under trend line options, you can extrapolate, which they call forecasting, forward or backward by a certain number of periods. And in the language of Microsoft Excel, a period, I believe, is equal to one major tick mark. So you have to look at what the major grid lines were here. I think they were half a unit, maybe a full unit, and that's what forecasting forward would involve. Yeah, 1.5. Every time I add 0.5 of a period, I gain 0.5 of an actual second of time down here. And you can do this backward as well. You'll start seeing the graph go into the negative region. Okay, so there are some options for making a graph, and if you've got to this point, you've pretty much done all that is necessary in most cases. For my grade 12s, there's something called error bars, and if you look in your course pack under the section on uncertainties, I did briefly introduce the idea of error bars on a graph. Error bars on a graph show what we have been referring to as these uncertainties here. If you know that all of your time values are plus or minus 0.1 second and your positions are plus or minus 0.2 second, then here's something you can do. You go under error bars. You go, since we're not dealing with a percentage here, we're dealing with a standard or an absolute error, you go like this. Now it's giving you what are shown as regions in which the true answer may lie. These are essentially plus or minus, but plotted on a graph. Again, this is all described in your course pack if you're not familiar with it. But what we want to do is go to options, and we want to input the actual value. So these are your X error bars. At a fixed value, I think we said the error bars for X were the time. Those were plus or minus 0.1 of a second, if I remember correctly. If you know them as a percentage, which is sometimes the case, you would select this. Don't worry about standard deviation. We're not really talking about that here. And you can play around with the styles here or some of the graphics, but basically, there's your X error bars. Error bar options, if we want to go for the Y error bars, now this is only showing the X error bars, so I think what you do is you click on the Y error bars, and now when you go to this, and you go error bar options, it's going to show the Y values. We said that the Y values were going to be 0.2 of a meter, and so voila, there are your error bars, which you can see not very clearly. They're not very large uncertainties, so they don't come out as very big error bars, but that is how you show them. Okay. Other things you may want to look at, axes. You can format the axes by going under axis options, which lets you say what is the minimum value, -2, right over here. What is the maximum value, 6, which is over here. Major units to go up in, ones, this is what was called period when we were extrapolating. The minor units are 0.2. This kind of speaks for itself. Where do you want the tick marks to be? Outside of the graph, inside the graph? What do you want them to look like? And so on and so forth. This is all just aesthetics at this point. The main part of the job is complete. All right? So just to finish up, let's have a look at the last thing, which is how to create drawings. I'm going to use Sketchbook Express. You may wish to use, I think Microsoft has something called Paint, whatever the case may be. I'm going to show you Sketchbook Express, which is actually the program that I'm in right now. It's got layers here. Each layer is kind of like its own little whiteboard. The active layer is whichever one has a blue square around here, and the little eye here hides or shows the layer. So if I want to type in a new layer, I have to click in here. Sorry, there are some announcements going on in the background here because I'm recording this at school. This is going to happen for a little bit because we're at the end of the day. But anyway, this is the active layer. There's a square, there's a box around it, and it's visible. As you can see, there's no X in front of the eye here. If you want to make sure you're not looking at any other layers which may contain stuff, just X them out like this. And now I'm ready to start typing something. So maybe I want to draw something like a table. Maybe a marble is rolling off a table. So table, rectangle. What color? Probably black. Everything's getting printed in black and white anyway when you hand it in. So there is your tabletop. I'm going to do a straight line here and show the floor. For those of you in my grade 12 class, this reminds me of a lab that we just did called the ball bearing bounce, which deals with projectile motion. And so you might do something like this. I want to show the launcher for the ball, which is rolling down. Here's a circle to make the ball. The ball starts over there. Down it rolls. Maybe I'm going to have an arrow here to show the ball going over the edge. There we go. There's the ball at a later time. Maybe the ball follows a parabolic path, which I'm going to show like this, and so on and so forth. If you want to type anything in, you go to the text box here and just sort of drag that out to the size you think you want to take up, and then you can start typing, like parabolic path of ball. Click OK. Now, when you insert something, this funny little circle comes up. If you highlight the outer perimeter, click and drag, that moves around the item that you've just inserted. If you go to the middle here, click and scroll down, it gets smaller. Click and scroll up, it gets larger, like that. So maybe I want to do something like this. Click X when you're satisfied. If you want to rotate, you can do that. If you don't like what you did, then for me it's Command Z, goes back a step, or you can just undo. You may want to include some physics symbols, in which case what I recommend you do is you go into Word and you go into the equation editor, and what you can do at this point is insert, for example, an equation such as accent vector hat symbol delta D. Now what I'm going to do, because I'm on a Mac here, is I'm going to set up a screenshot. Just going to take a quick picture of this. That's the sound of the camera doing a screenshot. Here I'm going to go File, Add Image. My screenshots go onto the desktop, so this is going to take me to my desktop where I have a screenshot waiting for me there. Click OK, add this in. Maybe this is the displacement of the ball. Just realize that if you've done a screenshot, it's probably captured some of the white area around what you took a picture of, and that will block out whatever you've already put into Sketchbook Express. So you may want to only screenshot a very, very small area around the item. Anyway, that's pretty much how you go about these equations. Once you're done, of course, save it as you normally would. Go save like this. And once you've saved it, you could do a screenshot of your diagram, like that. And then you could go back into Word, and if you wanted to put that into your lab report, go insert a picture from file. It's going to ask you where you want to get the picture from, and you're going to find that hopefully on the desktop, which is where the other screenshots were going. Here it is. And now you have a nice diagram in your lab report. Okay, folks? Anyway, that's about it. I hope that helps with designing your lab reports so they look professional. Once again, thank you for watching. Have a great day, and I will see you in class. Take care.